Okay, so we're going to start this video with objective 3 from section 3.1, and objective 3 is going to explain what it means for a statistic to be resistant. Okay, so the following data represent the travel time in minutes to work for all 7 employees of a startup web development company. Suppose a new employee is hired who has a 130-minute commute. How does this impact the value of the mean and the median? So this is the same exact data that we had in objective 1, where we found the mean and the median already. So before, from that objective number 1, the mean was 24.9 minutes and the median was 23 minutes. And if you remember, again, you can flip back. Again, that's the beauty of this being on a video. When we had added those numbers together earlier, we had gotten 174 as a sum, and then we divided by 7. That's how we got that. Okay, why do I say that? Because now all we have to do to figure out the new mean is just take that 174, add the 130 to it, and divide by 8. And when you do that, you're going to get an answer of 38 minutes. Okay, and the median, again, just don't forget to put your numbers in order first. They're not in order above. When they were in order before, 23 was in the middle. Okay, and now 23, because there's an even number of data, 23 and 26. Once you put your data in order, will be your two middle numbers. So if you take the mean of 23 and 26, that's how you get the 24.5 minutes. Okay, so before I switch slides, just want to point something out. Look at how different the mean is before and after. One was 24.9 and the other one jumped up to 38. That's a drastic difference. But look at the median. The median was 23 before, and now it's only 24.5. That's not that far off. So that's going to explain this next definition. A numerical summary of data is said to be resistant if extreme values, very large or very small, relative to the data, do not affect its value substantially. So again, what's going to happen if you flip back to that other slide and you look back at that data again, the mean was drastically different. So the mean in this case would not be resistant because it's drastically different. It's substantial difference. However, the median is resistant. That didn't change drastically. So that one would have been resistant in that case. Okay, so the relationship between the mean, median, and the distribution shape. Okay, so the distribution shape, we can have something that's called skewed left, we can have something that's symmetric, and we can have something that's skewed right. Okay, symmetric is the easiest one, and that's the one that's here in the center. Okay, and when you have data that's symmetric, your mean is going to be equal to your median. Okay, and then skewed left and skewed right. Skewed left and skewed right, in my opinion, seem different than the way my mind processes information. Okay, skewed left, when you look at A, means that your tail is to the left-hand side, but most of your data is over here on the right. So you're concerned about where that tail is, not where most of your data lies. So skewed left, the tail of your data is to the left. Skewed right, the tail of your data is to the right, and most of your data is on the left. So it's kind of opposite, I think, of the way you would kind of interpret it if I didn't just explain anything to you. Okay, when you have data that's skewed left, what's going to happen is the mean is going to be less than the median. And when you have data that's skewed to the right, the mean is going to be greater than the median. Okay, and just don't forget, when you're talking about inequalities, you can always change the order of the inequality as long as you're flipping the inequality symbol as well. So again, if for some reason you're doing a problem and you end up with the median on the left-hand side and then the mean on the right-hand side, and it ends up as a greater than symbol here, that's the same thing as that. Okay, remember the alligator from like 3rd grade? The alligator was eating the median here. The alligator is eating the median in the bottom. So these two inequalities are exactly the same. And the same thing goes for part C, for your data being skewed to the right. Your mean is greater than the median. And again, if for some reason you interchange those two words, again, this time the alligator was eating the mean, so I just have to make sure the alligator eats the mean on the bottom. So it flips that inequality symbol. Okay, so anytime that you have data that's skewed to the left, your mean is going to be substantially smaller than the median. Okay, again, symmetric means that they're going to be equal, and when it's skewed to the right, your mean is going to be substantially larger than your median. Okay, so in that last problem that we did, we had a mean that was much greater than the median, so that would be, your data would have been skewed right in that case. Okay, so now we have the following data represent the asking price of homes for sale in Lincoln, Nebraska. Okay, and there are 32 numbers here. Okay, be careful putting this into the calculator. That's all I'm going to say. So the first thing that we want to do is we want to find the mean and the median, and then we want to use the mean and the median to identify the shape of the distribution, and we're going to verify the results by drawing a histogram of the data, and eventually we're going to use our calculator to help us do that. So when you go to calculate your mean, again, the beauty of being able to stop, you can stop the video and you can add all 32 of those numbers together. But when you add all 32 of those numbers together, you should get an answer of 5,386,244. Okay, and again, there's 32 numbers there. So you're going to divide by 32. And when you do that, you should get 168,320.125. So if we're talking about the value of a house here, you can add a $sign to the front and we'll round to the nearest cent. Not that you're going to buy a house that's going to be rounded to the nearest cent, but whatever. It would be 13 cents. Okay, so this is going to be your mean. Okay, your median. Okay, again, just make sure that your data would be in order, and I was nice this time, and your data did go in order from smallest to largest, so you can just start counting your way to find the middle number there, or the middle two numbers here. Okay, and what it should come out to in the end is 148,700. I'm going to show you some more stuff in the calculator with that in a second, in case I didn't in class. Okay, so what does that mean? My median is less than my mean, or again, so it looks like what it did on the other slide. My mean is greater than my median. So if I want to know how my data is skewed, again, if my mean is greater than my median, that means that my data is skewed to the right. Okay, so the skewed part is the most important. But I do want to show you a couple things inside the calculator. Hopefully you remember. Now I have that Calculate 84 app on here. So it's not exactly the same as your graphing calculator, but for the most part it is. So hopefully you remember from regular algebra that you can actually find your mean, your median, Q1, and Q3 all inside the calculator by using that thing called one variable statistics. So a quick reminder of how to do that. If you go into what's called your list and edit your list, that's where you're going to put all your raw data. Okay, so I'm going to go into stat, and then you want edit, which is option number 1. So you're just going to hit enter, and then you're going to enter all 32 of your data values. And of course, I entered all 32 of my data values before I started this video. And I guess since I shut the app off, it erased all 32 of my answers. Lovely. Okay, but after you do that, nothing's going to come up here, but you can double check your work this way. You're going to go back into stat, and then you're going to hit the right arrow once to highlight calculate, and you want option number 1, which is one variable statistics. So you're going to hit enter. On your old calculators, on the TI-83s, you just have to hit enter once. If you have the CE or the 84, you're going to have to hit enter. I forget if it's 2 or 3 times. It's probably going to show me an error now. Yeah, it's missing content. But when you do that, what will come up? I don't want that. Sorry, you don't want geometry, do you? What will come up is a list of data values. And I'm going to try to remember the order, but I don't. Let's see. I think the first one is X with the bar. The X with the bar, that's what you're interested in. That's the mean. So as long as you put your information into the calculator right, you will see the mean as exactly what's written there. So it'll say X bar equals, and then that's going to be there. Then you have something that looks like that, which is your sum of your X values. And if you look next to your sum of your X values, you should see that numerator of the mean that I have over there. The next one is the sum of the x values squared. It's not important at all, but literally all they're doing is taking the step before and squaring it. Then I believe Q1 is next, then the median, and then Q2. And somewhere in there is also your standard deviation, which eventually we're going to get to. We have a sample deviation and a population deviation, which again, I don't know if they're in order right now, but that is what will come up. Hopefully I showed you this in class so you can actually see numbers next to it. Hi. But again, you can get the data right out of the calculator instead of doing it by hand. But the problem is, even if you were doing this inside the calculator and letting the calculator do most of the work for you, you still have to enter 32 numbers into L2, into L1, which could lead to a problem. Okay, so just be careful entering that data. I had one more thing I wanted to say about the calculator, but I seem to have a very short train of thought right now. I'm sure I'll remember. Okay. So let's move on to the next slide then. We're going to verify our result by drawing a histogram of the data. Okay, so we want to find the mean and the median. We did that, and then we want to use the mean and the median to identify the shape of the distribution. And again, we did that already. And we want to verify the results by drawing our histogram. And again, we had just found this on the last slide. Okay, the mean asking price is $168,320, and the median is $148,700. So again, that data is going to be skewed to the right. Okay, and then you can draw a histogram inside of your calculator. You may or may not have learned how to do this in regular algebra. Okay, if you haven't, again, I'll write what you need to do. If you follow what I write, it will come up exactly as it should. I can press the buttons on the calculator, even if my data was in there. We've already established that it's not, but even if my data was in there, for some reason, the Calculate 84 app won't actually draw the histogram. But again, all your raw data, Kara, that word's for you, all your raw data goes into L1. Okay, and then the next thing that you have to do is you have to turn on your stat plot. Okay, and in order to do that, you're going to hit the second button and then Y equals. So if you look above Y equals, you should see your stat plot, and you want to turn that on. Again, depending on which calculator you have, you might have to press the arrow key to highlight on, or you might have to hit enter to change from off to on. Okay, and then you want to go down to the next line, and you want to select the picture that looks like a histogram. Okay, and the one that is the histogram looks something like that. Okay, so you want to select that, highlight that, and then hit enter. And then once you do that, you're going to quit out of that screen. Okay, and then you're going to hit your window, and you're going to change your X-min and your X-max. Where are my X-min and my X-max coming from? It says in this right below here, if we start here, draw the histogram using your calculator, use a class width of 25,000, your lower limit is 50,000, and your upper limit is 349,999. So this 50,000 is going to become my X-min, and my X-max is going to become that 349,999, and I'll just make it 350,000. And then all you have to do is press zoom and then the number 9. And again, your histogram should pop up. And when you see it, you will see your data is skewed to the right. Again, that means that most of your bars are going to be to the left and the tail is going to be to the right. Okay, and there you go. So this is what it should look like once you plug it into that calculator. Again, the tail is to the right. Most of your data is to the left. And again, that's skewed right. Okay, it is the complete opposite, I think, of the way you would look at it, the way you think it should look. Okay, so let's go ahead and describe the shape of these distributions. Okay, so for part A, again, the tail is to the right. You care about where the tail is. Okay, so that is going to be skewed right. And then we want to determine whether that means the mean is greater than, less than, or approximately equal to the median. So again, since this one is skewed right, again, the two different ways to look at it. The median is less than the mean, or again, if your brain flips it around, it's fine either way. Your mean is going to be greater than your median. Okay, alligator ate the mean there, and it's eating the mean down here. Part B, this is the one that's pretty symmetric. Okay, so for a symmetric, that's the shape. Okay, and in this case, that means that your median is equal to your mean. And then for part C, this time your tail is to the left side, so that means this data is skewed left. Okay, and when the data is skewed to the left, that means the mean is less than the median. Or again, if you flip that around, the median is greater than the mean. Okay. This skewed left, right, and symmetric is going to keep coming up now over and over throughout the rest of the course. Okay, so now we want to determine which measure of central tendency is better. And hopefully you almost even have an idea of what the answer is going to be here based on that definition of what it means for data to be resistant. Okay. So if the data are roughly symmetric, then the mean is the best measure of central tendency. So if you have no outlier, okay, the mean is going to be the best measure of central tendency. If the data are skewed, so if you have a data value that's substantially bigger or smaller than all your other data values, and again, that's called an outlier. If you have an outlier, the median is going to be the better measure of central tendency. Again, why? Because the median is resistant, the mean is not. Okay, and then we're going to talk about how to find the mode of a variable from raw data. Raw data. Okay. By the way, depending on who you had for algebra, sometimes its mode technically isn't part of the algebra curriculum, but inherently, as when you teach statistics, if you talk about the mean and the median, really the mode is also usually right in there. So depending on who you had for algebra, you may or may not have learned the mode. Okay, it's very easy though. Okay, so the mode of the variable is the most frequent observation of the variable that occurs in the data set. Mode starts with MO, and so does the word most. Okay, so the set of data can have no mode, one mode, or more than one mode. So the only time it's going to have no mode is if you just have a list of numbers and not one single number repeats. Okay, you can have one mode, so that's going to be fairly obvious. Again, you can have one number that repeats 5 times, one number that repeats twice. The number that repeats 5 times is going to be the mode. Or you can have more than one mode. If you have more than one mode, numbers would have to repeat the same number of times. So here, for 1, 1, 2, 2, and 3, there would be 2 modes there. The mode would be 1 and 2 because they both occur 2 times. Now, let me add another 3 on there. When I add a number 3, now all those numbers happen the same number of times. They all happen twice. That does not mean they have no mode. Something repeated. The second something repeated, there's definitely a mode. So in this case, this would have 3 modes. So your modes would be 1, 2, and 3. Okay, so to have no mode, it's a single list of numbers and not one single number repeats. The second something repeats, you can have one mode or more than one mode. Okay, so the data on the next slide represent the vice presidents of the United States and their state of birth, and we want to find the mode. Okay, so here is our list. And then we can sit and we can make tallies here. Again, the beauty of this being a video, you can stop and you can check my tallies. But when you do this, you should end up having 3, 2, 2, 8, 1, 4, 2, 2, 2, 1, 3, 3, 3, 1, 2, 1, 1, 1, 1, 1, 2, 1, and 1. So the one that has the most here is 8. So New York is the mode. That's because New York is the best state. Okay, so how do you know about these measures of central tendencies and what they mean? Again, the mean is the first one on here. We have a population mean. I'm going to say median 14 times. The mean, you have a population mean. So that, again, is going to be every single data value in your set. So you're going to take, again, that means the sum of your data values and divide by the number of values that you have. Or again, you can take a sample. So if I have 20 data values and I want a sample mean, I can take 3 of those data values and then take the sum of that and divide that the number of that there are. Again, you're going to see this a lot throughout the year, like a ton from now until June. Okay, that is the mean. That is technically the mean also, but this is the sample mean. This is the population mean. Okay, and when you're going to use that, when data are quantitative and the frequency distribution is symmetric. The median, don't forget they have to be arranged in order from smallest to largest before you find the halfway point, and it divides your data into the lower 50% and the upper 50%. And when the data are quantitative and the frequency distribution is skewed left or right. So when you have an outlier of your data set, the median is going to be the best representation. And the mode is just a tally, and it determines the most frequent observation. Okay? And when the most frequent observation is desired, the measure of central tendency or is going to be qualitative, just like it was on the other one. New York is not a data value. It's not a number. It's a qualitative. It's just a name. And that ends that. I just remembered what I wanted to say about the calculator again. Now I can't remember. I just remembered when I turned onto this slide and I said, let me finish my train of thought and then I'll go back to what I was going to say about the calculator. And of course I forgot again. Can't be that important. All right, go fill out that Google form. Have a good night.